Hello, this is Anna from CS department. I've come here to record my 8th experiment of my Unix lab, and this is about the process creation. Normally, in a process creation, you'll be having the parent ID and the child ID, and that is what we're going to do today. So the first question is about we have to get the seconds through process A, and we have to calculate the hours and minutes using the process B, and we have to print the process ID for both. So let's go to the program. So this is my program. Yeah. So as you could see, my program is in the C language. I have got all the header files that is needed, and then the PID. PID is the process ID, where the process is going to get the seconds. That is, process A is going to get the seconds, so that the process B can access the hours and the minutes. So in the process A, first we'll be printing the process ID of process A. Then if the process ID is equal to 0, that means if it's a newly created process ID, then it will be displayed as a child process, along with the parent ID will also be displayed. And then we have to enter the seconds that we need, so that the process B will be able to calculate the hours. And this fork system call has been invoked as because the child process is being invoked using the process ID of the parent. And finally um, and finally the process is going to calculate you. So when I'm going to give into seconds, the seconds are going to get converted into hours and then minutes, and then finally you will get an overall calculation of hours, minutes and seconds. And finally it will be printed along with process ID for each and every single process, along with the parent ID. So this is about the program. Let's see the output. So as it is in C, so GCC. Yeah. So I have to enter the seconds. I'm giving 86 seconds. So as you could see, the seconds has been calculated as we saw in the program. The process B is calculating, it's a child process. So it's giving you the parent ID along with the child ID, and as you could see, 86 seconds has been converted into hours, minutes and then seconds. And this is about the first program. And the second one is we have two child node along with one parent node, and which is we are going to get a string as input from process A, and we are going to reverse the string and check whether it's a palindrome or not. And similarly we have to display in the ID. So going to the second program, so it's the main purpose of this is to reverse the string and check whether it's a palindrome or not. As you could see, the header files are already been imported, and then as I said, the process ID is so the parent process ID is being initialized, and then as I said, the child process will be invoked using the fork system call, and then the process ID, if it's equal to 0, then the output will be printed as it is a child process along with the parent ID, and then the string will be reversed. After reversing the string, we have to use the logic for the palindrome, as we could always use the same thing for all. And so we have to compile each and every single string. So the string is given, so the string will be compared, so the center letter will be kept and it will be compared from one and the last one. And finally we have called this sleep system call, as once the palindrome has been set, the system call will go to sleep. That is, the child system call will go to sleep, and later then the parent process ID and the child process ID will be displayed. So this is the output. So you can see the parent process has already been displayed, and we have to enter the string. Yeah. So as you could see, I've entered a name called Hannah, and you can see the string length, child process, and as I said, the process ID will be referred if the fork system call has been invoked, the child process. If the process ID is equal to 0, then it will be a child process, and then it's removed. And finally you get to know it is a palindrome. And then coming to your third question, Third one is we have to perform factorial Armstrong Fibonacci series, number of prime and reverse the numbers. We have various child process connected to 2 to 3 parent nodes, but the main root node is only A. So we got to just enter an integer which is going to get you an output along with your process ID and the parent process ID too. So this is my third program. So the header files have been imported as I said, and then get PID. So the process ID is being initiated, that is process A is the parent ID with, so, yeah, it is a parent process with an ID, and then we have to enter an integer. If the integer has been invoked using the fork system call, then your child node will be checked using if the process ID is equal to 0, and then process B will be created. We know the process P have to check whether it's a factorial, so the logic for the factorial has been written, and then if it's factorial, then it will create the process D, which is going to check whether it is a Fibonacci series, and then it'll go to sleep again. And then after the child process has been invoked using another fork system call, the process C will be created, which is going to check whether it is an Armstrong number or not. And then after this process process ID 3 has been invoked after my Armstrong number, the process E is going to get created, which is going to check whether it's a prime number or not. And then later the fork system call will go to sleep. Yeah, and then later the next system call has been invoked using the fork, and then the process F has been created, that is going to check whether the number is a reverse number or not, and finally the process will go to sleep, and finally your process ID will also be executed. So now let's see the output. Yeah. So yeah, as you could see, the parent process A has already been initiated with an ID given, and I have to just enter the integer. So an integer has been already be entered. So you could see, I will show you with the better view. So yeah, so I have entered an integer called 65. You can see the process B is being created, and then you can see the child process ID and the factorial number of 65. Process D, then the Fibonacci series of the old number 65 is being given. Then process C is created. It displays whether it's an Armstrong or not. It's not an Armstrong. Process E is created to check whether it's a prime number or not. It's not a prime number. And finally, to check the reverse, it has the reverse. So it is 56. So that's all about this eighth experiment using the process creation. Thank you so much for watching my video.